Hey there, Earth Science. This is Kolpak. I'm here in DC at a place called the Mall, which is where all the monuments are. There's the Smithsonian Castle, the Washington Monument, the Capitol Building, and a definite must-see on any stop in DC, the Natural History Museum, the Smithsonian Natural History Museum. And we're going to go in there and check out some moon rocks, and some Mars rocks, and some meteors. Alright, so stay tuned for that. Guys, I'm sitting in front of this huge iron meteorite that was found in California. This is a really cool place. I just heard a movie about some meteors they found that crashed in Namibia billions of years ago. It's just a room with glass cases all around me filled with meteors that they found from places in the world. Check it out. It's wild. This thing behind me is probably like as heavy as a motorcycle. Anyway, next time I find something really cool, I'll stop and clue you guys in.
The solar system had a brilliant beginning here at the edge of the galaxy known as the Milky Way more than 4.5 billion years ago. Suddenly, a star explodes, throwing off an enormous burst of matter that sweeps through space and collides with a vast cloud of dust and gas. The impact shatters the cloud, leaving behind many small, dense clumps, each to become a new star, one to become our sun. In that clump, the gas swirls and churns and begins to rotate faster and faster, shrinking into a broad, flat disk. Matter spirals toward the center, creating a massive nucleus that begins to heat up and emit light, our infant sun. Great jets of hot gas shoot out from the holes into space. Deep within the disk surrounding the sun, small bits of dust stick together, sweeping up more and more dust until the particles become rocks, and the rocks, large bodies. Collisions between these bodies are violent. Many are destroyed, others spared. In the cold outermost part of the disk, 4 large bodies of ice and rock attract immense blankets of gas, eventually becoming the gas giant planets. Close to the center, the smaller ice-free bodies retain little gas, becoming the rocky planets. Finally, the gas in the disk dissipates, leaving the planetary family we know today. In the nucleus itself, rising temperature and pressure trigger nuclear reactions, and at last our star, the sun, is born. But the story isn't finished yet. The third planet from the sun, Earth, nears its present size when a large body crashes into it and rips away part of the Earth's mantle. A halo of hot debris quickly encircles the planet and coalesces into our moon. Even today, the violence goes on, as collisions continue to transform this planet and the many other bodies spinning around our sun.
Alright, that might not look like much, but that is a piece of the moon. It's a piece of anorthosite from the lunar highlands. Radiometric dating places it at over 4.5 billion years old, about as old as the moon and the Earth. And it was brought back by the Apollo astronauts back in the late 1960s, early 1970s. Wow, a piece of the moon right here. That little black rock in there, that's a piece of Mars. According to this exhibit, 10 million years ago, it got blasted by a meteor. Mars got blasted by a meteor, and some of it got knocked off, and this piece got lucky enough to land here. The rock itself is just over 1 billion years old, so I'm touching a piece of Mars. Cool. I didn't actually take a picture of the stardust, but because it wouldn't have come out, it's really small. But read this, it's amazing. This thing is older than the solar system. This is a really cool place, guys. If you ever come to Washington, you gotta promise me you'll stop in here, even if just for half an hour. There's no admission fee. Stay as long as you like. There's a big elephant down there. You see him? There's rocks. There's stuff about astronomy. It's basically like an earth science class, all in one building. There's a gift shop, a restaurant. It's just too cool. So I hope you all make it here someday. Alright, that's the end of our day at the museum. Kopak out.